Welcome to my class 12 physics. Today we will discuss a new topic, that is electrostatic potential. But before discussing this topic, electrostatic potential, let us recall some basic concept of electrostatic potential energy, which we have already discussed in the last class. What is electrostatic potential energy? Electrostatic potential energy means basically that is the work done by the force. In this case, we take two charges. One is your source charge, that is plus Q, capital Q, situated at the point O point is the origin. Another charge is there, second charge, that is known as the test charge. Initially test charge is situated at infinite. Then what happened? Both the charges are positive, so that the source charge repel the test charge along this direction. That means electrostatic repulsive force is applied on this test charge, and we write that electrostatic repulsive force, that is Fe. Then here we applied external force, that is F external, and direction of this external force is just opposite to the electrostatic force, and magnitude of this external force may be equal to the electrostatic repulsive force or slightly greater, not less, slightly greater than the electrostatic repulsive force. Then what happened? Now the test charge starts to move from infinite up to point P. That means displacement is there. If the test charge starts to move from infinite up to point P, some work is done. Some work is done by this external force against the electrostatic force, and that work done by this external force is known as the electrostatic potential energy. And this is the definition of the electrostatic potential energy. We have studied this. Clear? And you also know what is work done. You know this formula, mathematical expression of the work done. Work done W is equal to force multiplied by displacement. You know this. You know this expression. Here also same thing. Work done. When the test charge moves from point infinite up to point P is equal to integration of this one, because this one is the force, external force, and this is the displacement. And this is the mathematical expression of the work done. And this work done is known as the electrostatic potential energy. And in this case, test charge is Q. Remember this, test charge is Q. That is not unit. That is not unit positive test charge. That is simply test charge. In case of electrostatic potential energy, we take a test charge. Its magnitude is Q. That is not one unit. That is not unit. Its magnitude is Q. Remember this always. But before discussing the electrostatic potential, here we take two assumptions. First assumption, we take the test charge. That is plus Q0, and its magnitude here, that is 1 coulomb, that means 1 unit. Magnitude of the test charge, that is 1. We take a unit positive test charge. In case of electric potential. But in case of electrostatic potential energy, we take a test charge, not unit positive test charge. That is the difference. Once again, in case of electrostatic potential energy, we take a test charge and we write that is plus Q. But in case of electrostatic potential or electric potential, we take a unit positive test charge. We write that is plus Q0. Its magnitude is equal to 1 unit. Only this is the difference. Only this is the difference between your electrostatic potential energy and electrostatic potential. Clear? And magnitude of this test charge is very small. Is very small. That means it does not disturb the charge Q. Magnitude of this test charge is very small, so that it does not disturb the original source charge plus Q. But in this case, we take a unit positive test charge. This is the first assumption. Second assumption, you also know that here electrostatic repulsive force is there. We applied an external force, and magnitude of the external force is just equal to the electrostatic force. Both are equal and opposite, so that we write external force is equal to negative of electrostatic repulsive force. That means net force applied on this unit test charge is 0. If net force is equal to 0, you know the formula for force, that is mass into acceleration, that is equal to 0. Mass of the charge is not 0. So that we write from this expression acceleration is equal to 0. Acceleration is equal to 0. That means without any acceleration, the unit positive test charge moves from point infinite up to point P without any acceleration. Without any acceleration means its speed always remain constant. Its speed always remain constant, and that is slow. Clear? These are the mainly two assumptions. Now the next point of this chapter, that is the electrostatic potential. What is electrostatic potential? Same thing. We take a source charge, that is plus Q, capital Q, situated at the origin O. We take another charge, that is known as the unit positive test charge, initially situated at infinite. Here also two charges are there. Clear? And you know electrostatic potential energy, that is the work done. That means work done is equal to dot product between the force and displacement. We know this expression. You also know the formula for electrostatic force. Electrostatic force F is equal to charge multiplied by electric field. Force is equal to charge multiplied, charge means here this is the test charge, not the source charge. Q multiplied by E. That means if we write in place of F Q into E, so that work done W is equal to Q E dot dr vector. That means from this expression we write work done is depend upon the test charge. Work done is depend upon the test charge. Clear? If we divide the work done, with Q, then we write W by Q is equal to, gives another quantity, and this quantity not depend upon the test charge. This quantity not depend upon the test charge. So that this quantity is known as the electric potential in this case. That means simply work done. Work done means that is the electrostatic potential energy. Electrostatic potential energy or work done divided by test charge gives the electric potential. Clear? Or same thing, if in place of Q, suppose we take 1, that means if test charge is 1 unit, If magnitude of the test charge is 1, then W is equal to electric potential. This is the definition of the electrostatic potential. What is this? Here force is applied on this unit positive test charge because source charge is positive, test charge is also positive, so that electrostatic repulsive force is applied, and here another external force is there. Magnitude of this external force is equal to the electrostatic force, and the direction is just opposite. Then what happens? Now the unit positive test charge starts to move from infinite up to point P. Then some work is done. Some work is done by this external force. Some work is done by this external force when the unit positive test charge, moves from point infinite up to point P without any acceleration, and that is known as the electrostatic potential. Symbolically we write V, and this is the definition of the electrostatic potential, and this is the mathematical expression of the electrostatic potential. That means here unit positive test charge moves from point infinite up to point P. P is the final point. P is the final position. So that we write electric potential at point P is equal to work done when the unit positive test charge moves from point infinite up to point P divided by unit positive test charge. That we simply write electric potential is equal to work by test charge. Work by test charge, not source charge. Clear? And electric potential, that is a physical quantity which determines the flow of charge from one body to the another body. Electric potential determines basically the flow of the charge. Charge means that may be positive charge or that may be negative charge from one body to another body. Suppose you take two body. One is higher potential and another is lower potential. Higher potential means concentration of the positive charges are more. Lower potential means concentration of the positive charges are less as compared to the first one. Or you also write first one, that is positive charged, second one, that is the negative charged, same thing. Then what happened? Now the positive charges starts to flow from the higher potential to the lower potential. Or we also say that the negative charges starts to flow from the lower potential to the higher potential. That means simply we write electric potential that determines the flow of charges from one body to another body. That means from higher potential body to the lower potential body, from higher potential body to the lower potential body, positive charges are moved, and from the lower potential to the higher potential, negative charges starts to flow. Clear? If source charge is positive, then potential is positive. You know that. That means potential may be positive, that may be negative, depending upon the source charge. If source charge is positive, electric potential is positive. But if source charge is negative, then what happens? If source charge is negative, suppose this one is the source charge, we take a negative source charge, that is minus Q, then what happens? If we take a negative source charge is negative, this one is the test charge, that is positive, so that the negative source charge attract the unit positive test charge in this direction. This is the direction of the electrostatic force, and this is also direction of the displacement. Here direction of the displacement and the direction of the electrostatic force, both are in the same direction. Both are in the same direction. Same direction means angle is 0 degree. So that work done is positive, because you know the formula for the work done. That is, we write work done W is equal to F vector dot displacement vector. We also write that is F R cos theta, and your theta is equal to 0 degree. So that we write F R cos 0 degree. Cos 0 means 1. So that work done is positive. We write that is plus F R. But direction of the external force we applied, that is just opposite to the electrostatic force. If direction of the external force is just opposite to the electrostatic force, then work done is negative. How? If we take electrostatic force, direction of the electrostatic force is same as direction of the displacement. So that work done is positive. If in place of the electrostatic force, if we take the external force, then angle between the electrostatic force and external force is 180 degree. Cos 180 means minus 1. That means work done is negative. Work done is negative. So that electric potential is also negative. Clear? That means finally we write, if source charge is positive, potential is positive. If source charge is negative, electric potential is negative. Clear? And you know electric potential is also 0. Electric potential is 0 at infinity distance. That means finally we get electric potential may be positive, may be 0, may be negative. Clear? If we take at infinite distance, potential is 0. If source charge is positive, potential is positive. If source charge is negative, potential is negative. Very simple. And electric potential, that is a scalar quantity, because work done, that is scalar. Work is scalar. So that electric potential energy, all are the scalar quantity. Next point, that is the unit of the electric potential. And you take the SI unit of the electric potential. We know the mathematical expression of the potential, that is potential is equal to work done divided by test charge. And you know the SI unit of the work done, that is joule. And you also know the CGS system unit of the work done, that is arc. And you take the SI unit, that is joule, and SI unit of the charge, that is coulomb. So that we write SI unit of electric potential, that is joule divided by coulomb, or we write joule into coulomb inverse. And in place of joule coulomb inverse, simply we write that is volt. That means SI unit of electric potential, we write volt. Volt is a name of the scientist. And symbolically we write that is capital V, because that is a name of the scientist. And here in place of joule we write Newton into meter. That means SI unit of electric potential, we may be write volt, we may be write joule into coulomb inverse. We also write that is Newton meter into coulomb inverse. Clear? Then what is the definition of the volt? What is the definition of the 1 volt? Here we take a positive charge, unit positive charge, that is plus Q0, and magnitude of the unit positive test charge, that is 1 coulomb. We take a unit positive test charge, its magnitude suppose 1 coulomb, and the unit positive test charge moves from point infinity to a point means that is the P point, against the electrostatic force of the field without any acceleration, You know that. Then work is done, and that work done is 1 joule. That means simply look at the figure. Simply suppose a unit positive test charge is there initially at infinite. Its magnitude is equal to 1 coulomb. Then the unit positive test charge of magnitude 1 coulomb starts to move from infinite up to point P. Some work is done, and that work done is equal to suppose 1 joule. Then potential at point P is known as the 1 volt. Potential at point P is known as the 1 volt. This is the definition. This is the definition of the 1 volt. That means when 1 joule work is done in moving a positive charge means that is the unit positive test charge of 1 coulomb from infinite to the point P against the electrostatic force of the field without any acceleration. Then the potential at that point means at point P is said to be 1 volt. Clear? And what is the dimensional formula of electric potential? We know the formula for the electric potential. Electric potential is equal to work done divided by charge, that is the test charge, and you know the dimension of the work done. That is, this is the dimensional formula m1 L2 t to the power minus 2. You also know the dimensional formula of the charge, that is A1 T1 A for ampere, T for time, M for mass, L for length. And finally we get, that is M1, we write M1, L2, we write L2, T, here 1 is there. If we take to the upper side, that is minus 1. So that minus 2 minus 1, that is minus 3. If we take A to the upper side, that is A to the power minus 1. That means this is the dimensional formula of the electrostatic potential. Clear? And this is all about your electrostatic potential. And another point is that is your electrostatic potential difference. What is electrostatic potential difference? Its definition is same as electrostatic potential energy difference. Definition of electrostatic potential difference is same as definition of electrostatic potential energy difference, but only one difference is there. What is that? In case of electrostatic potential energy difference, we take a test charge, its magnitude is Q, but in case of electrostatic potential difference, here also we take a test charge, but its magnitude is not Q, its magnitude is only 1 unit, only that is the difference. Look at the figure. This is the source charge, you know, that is plus Q. This is the test charge, and here that is the unit positive test charge. Its magnitude is equal to 1 coulomb. Initially, the unit positive test charge situated at point R at a finite distance, not infinite distance, so that potential at point R we write that is VR. Now, by the external force, the unit positive test charge starts to move from R to P. So the displacement is there, force is also there, work is done by this external force, and that work done by this external force when the unit positive test charge starts to move from one point, means that is R point, up to point P. That work done is known as the electrostatic potential difference between point P and R. Clear? And if we compare P point and R point, potential at point P is greater, as compared to the potential at point R, because your source charge is positive, that is a plus Q. So that what is the electric potential difference? We write electric potential difference, that is Vp minus Vr, or you also write same thing. This is the electric potential at point P, because you know the formula for the electric potential, that is the potential energy divided by test charge. This is the potential energy UP divided by test charge, minus this is the potential energy at point R divided by test charge. So that finally write electrostatic potential difference, that is Vp minus Vr, or we write simply del V. And this is all about your electric potential and electric potential difference. Clear? And in the next class we will discuss about a new topic, that is electric potential at any point. Electric potential at any point due to a charge, due to a point charge. Clear? Thank you.